Right, let's take a look at question 1 from June 2013. It's quite a nice question. Make sure it tests you on your prefixes and your defining equations. So let's just have a little look what we've got to do. So you've got these statements written out. The first one's done for you. There's a mistake that's been circled in the statement, and then here's the correction over here, and you've got to do the other 3. So let's just have a little look. Let's just get myself a pen. Okay, so the atmosphere exerts a pressure of about 1.0 times 10 to the 5 Newton meters squared. Well, what's wrong with that? Well, pressure is defined as the force per unit area. So if we were going to look at this in terms of SI units, the SI unit would be, the force is the Newton, and of course we're dividing by the area, so that should be meters to the -2, or if you wanted to, you could say that that was a Pascal, but I think that's what they're trying to show or want to see, although I'm sure if you wrote Pascal in there, that would be fine. Let's look at this third one then. A force of 1 Newton may be written as 1 kilogram, meters to the -1, seconds to the -1. Well, what's wrong with that? Again, the defining equation for a force is, well, strictly comes from momentum, but we'll go with ma. So the Newton is going to be a kilogram multiplied by the unit of acceleration, which is meters seconds to the -2. So that's what they're looking for there, is meters seconds to the -2. And the 1 gigawatt is 10 times bigger than 1 megawatt. Well, let's go up here. A megawatt is 10 to the 6 watts, and a gigawatt is 10 to the 9 watts. So it's not 10 times bigger, but it's a 10 to the power 3 bigger, or 1000. So now on to part B. We've got these 2 figures, and they're showing us how the apparatus used to determine the density of glass. We've got a test tube here, we've got a measuring cylinder with a line going up to 75 centimeters cubed, and then what they're going to do is they're going to submerge the test tube in here, and we notice that now the measuring cylinder's line is up to 82 centimeters cubed. It tells us that the mass is 1.6 times 10 to the -2 kilograms. The measuring cylinder is partly filled with water. The test tube gently we increase in the volume of the water from 75 to 82. Now we need to calculate the density of the test tube in kilograms per meter cubed. So first thing we need to realise is how many centimeters cubed are there in a meter cubed. So let's just have a little sketch of that. Well, there are 100 centimeters in a meter, so that's 100 times 100 times 100, which tells me that I've got 10 to the 6 centimeters cubed is equal to 1 meter cubed. So the volume of our test tube is 82 centimeters cubed minus 75, which is 7 centimeters cubed, but of course we want that in meters cubed, which is 7 times 10 to the -6 meters cubed. Now we've got our volume in the correct unit. The density is defined as being the mass divided by the volume, so now I could just simply substitute in, and that will go 1.6 times 10 to the -2 over 7 times 10 to the -6, And if we put those into our calculator, it will come out with a density for glass of being, let's just write it up here, 2.3 times 10 to the 3 kilograms per metre cubed. And that looks about right. Water is 1 times 10 to the 3 kilograms per metre cubed, and it clearly sinks, so I'm happy with that answer.